All right, so one last example for this section. At first, it looks a little intimidating, but once you understand what the summation notation is speaking about, especially when they're asking us to evaluate the summation, you're noticing that the argument ends up being a function. And we've been actually doing this, but this notation f of x sub I multiplied by delta x becomes very popular. You use it a lot when you're dealing with Calc 1, when you're kind of finding areas under curves, so you're approximating. It's very, very interesting to be able to multiply these out by hand, or should sum these up by hand. So we're going to practice it that way. So we'll just kind of space it out. First thing I do, anytime I see summation notation, what I like to do is write out based on what it means after I take it out of summation notation. So we'll start off with the summation. I going from 1 to 5, f of x sub I multiplied by delta x. So I just like to write out all of those terms, as long as the last term is not too high. That's only 5 terms. What this just means is we're basically taking our f of x sub I times delta x, and we're just plugging in I equals 1, I equals 2, and so on. So starting off, we have f of x sub 1 times delta x plus f of x sub 2 times delta x plus f of x sub 3 times delta x plus f of x sub 4 times delta x, and one last one, plus f of x sub 5 times delta x, that triangle, delta x. So kind of keeping in mind, what is changing is the subscript. So notice that it's varying based on the summation notation. So once you understand that, what happens is you have to figure out, well, who is f of x? F of x, let's find it. Aha, f of x is given by the formula x squared minus 3. Now, what I'd like to do for myself, I'll kind of write it out expanded, but if you'd like to compute what is f of x sub 1, what is f of x sub 2, that could be useful too. I'll kind of do it both ways for you. So f of x sub 1, what do we have is x sub 1 squared minus 3, which gets multiplied by delta x, plus, again, f of x sub 2. All they're doing is changing the subscripts on the x's. So it's just saying you have different variables for the x. Still multiplying everyone by delta x. Checking this out, do this again. Plus, we have f of x sub 3. So we have x sub 3 squared minus 3, still multiplied by delta x. Take our time. F of x sub 4, we're adding that. It's kind of showing you where my function notation is coming from. That is x sub 4 squared minus 3, still multiplied by delta x, plus, one last time, f of x sub 5. So pretty much, it's x squared minus 3, but the subscript is a 5. Multiplied by delta x. Now, if you look at this a little closer, you will notice that delta x, you see it right here, it's actually a constant. And it is, it's a very small distance. So technically what you could have done, instead of having to write out delta x all this time, you could have factored out this constant at the beginning. So we could have done that at the beginning if we'd like, but we'll deal with it now. So what this means is I pretty much have to find what is x sub 1 squared minus 3, what is x sub 2 squared minus 3, and x sub 3 squared, and so on. Well, lucky for us, they've actually given us the values of all the x's. So just take some time on this. It may be useful if you're interested. You may want to plug in what your function notation is. I can do this off to the side, but I'll kind of combine it for you. We have equals. You know, what is x of 1? Let me use a teal color. So x of 1 is 0. So what we end up really having is 0 squared minus 3. And actually, I want to save some time. So I'm going to factor out delta x at the very beginning and go from here. And just bear with me for a second, if you don't mind. I don't want to skip steps and confuse you too much, but there are a few ways we can play with these. All I'm doing is factoring out the constant delta x, and we already know that it's equal to 0.2, so you could actually plug that in right after. So let's write this in. X of 2 squared minus 3 plus x of 3 squared minus 3. And don't let the subscripts fool you. All they're trying to tell you is that you have different values of x to plug into your function. X of 4 squared minus 3. And we're not writing the delta x because it's already factored out. Oops, I want to highlight that. There we go. It's already factored out. Plus x of 5 squared minus 3. So if you're trying to find all of these numbers, you can directly plug in. What is delta x? Delta x is 0.2. I shall plug that in for myself. 0.2, keeping in form. That's what they're telling us what delta x is. And now, pretty much what's happening is you're finding these values. So whether or not, I'll kind of do this off to the side afterwards, but if x of 1 is equal to 0, what do we really have is 0 squared minus 3. Okay, keep going. Just kind of think about what is x of 2 equal to? X of 2, I'll kind of alternate. X of 2 is equal to 5. So what do we have is 5 squared minus 3. What is x of 3 equal to? That's equal to 10. So what are we plugging in? 10 squared minus 3. Just kind of keeping my idea of what I'm plugging in. Plus, well, what is x of 4? X of 4 is 15. So we'd be looking at plugging in 15 squared minus 3. Add it one more time. X of 5. That is equal to 20. So we're technically looking at 20 squared minus 3. So this is just function notation, and you guys have been dealing with function notation. You're pretty good at this. So now all it is you simplifying a little bit more. Take some time on this. We should have 0.2. We're still multiplying everyone by this. Now it's just a matter of saying, well, what is 0 squared minus 3? Well, that's negative 3. Add this. What is 5 squared minus 3? 25 minus 3 is 22. We're adding this to what is 10 squared minus 3? 10 squared is 100. If you take away 3, you're going to get 97. Add that. What is 15 squared? 15 squared is 225. Need a little calculator for that, I'll be honest with you. So that's going to be 225 minus 3, which is going to leave us with 222. And then we have 20 squared, that's 400. 400 minus 3 is 397. Let's write that in. So now you have a expression which you just have to add the terms. Probably use my calculator for this. I do believe when I add them all together, so all of this is going to equal 735. And then all you do is use your calculator to multiply that by 0.2. So let's just double check that really quick. I feel like I have it written down somewhere, and I've done this problem a lot of times, but I just want to verify with you. So all I'm doing really quickly, just adding those terms. And I'll show you kind of a shortcut in a second, just so that you can do these together. So what I have, -3 plus 22 plus 97 plus 222. Oh, careful, there's an extra plus sign. Plus 397. So that is 735. If you multiply it by 0.2, we end up getting 147. I'll switch that back over. We were correct. We'll help with the calculator. The value of our problem is 147. So that's if you're kind of expanding everything out by hand. There is a nice, there's kind of a, like, I don't know if it's nice, but there's a mini shortcut you can play with. I prefer, if I see function notation and I know if I'm thinking that I have to find multiple values of f of x equals x squared minus 3, I might use my table feature to help me out with this. So if you don't mind, I'll do this one more time. Just kind of helping you look at it in a few different ways. So here I have the summation I going from 1 to 5 of f of x of I times delta x. And one of the ways we look at it, if we're going to understand delta x, see if I highlighted, it was in pink, right? As long as delta x is a constant, it's actually equal to what, 0.2? You can pull that directly out of the summation, because every single time it was pulled out and then we took the summation of the remaining function terms. So you can actually pull that out. It's a little property of summation. If you don't mind, I'll do this with you. Take a little bit of a liberty. You're actually pulling out delta x in front of it. That's getting multiplied to the entire summation. So kind of a mini shortcut. Summation I equals 1 to 5. Let me make that summation a little prettier. F of x of I. Now, if you'd like to, you understand that's getting multiplied. You can say, hey, I already know delta x is 0.2. So all my job is to understand, what is this f of x of I business telling me what to do? So what we're looking at, I have 0.2. And summation notation would be telling me I'm going to take all of this f of x business, f of x of I, and all we're simply doing is, no, we still have to plug in f of x of I, Leica, so give me 1 second. So f of x of I, starting off with 1, that'll be added to f of x sub 2, added to f of x sub 3. How many more do we have to go? Just 5? Thank goodness. So f of x sub 4, all it is kind of a counter. Who doesn't love counting? F of x sub 5. Okay, so you're saying, I know that's function notation. I remember them telling us that f of x is actually, there's a formula for that. That is x squared minus 3. So why don't we use our TI to actually find values of this? We don't really have to spend our time showing our work, what we're plugging in, unless we're looking for some sort of pattern. So let's pull up our TI to do this. And I'll use a table feature. And I know we're coming full circle because I think we used a table feature in chapter 1. Let's go back. And now remember, if you're using the table feature, enter your function into the function editor. Let's erase everyone else. And actually what I'd like to do, see if it'll let me clear everyone. I just want to make sure I don't have any more shading, so give me a moment. Let's change it back to a line. I don't think it's going to make a difference. So all I want to do is enter it into Y1. So all I'm doing is entering x squared minus 3. So that's x squared minus 3. Minus 3, not negative. Be careful there. Now we go to our table. So you can press second graph. And if you haven't done so already, you probably already have it set up, but you could go to the table setup and just make sure your independent variable, that is the x variable, is highlighted as ask. So if it's not, move it over, press enter, and dependent should be automatic. So let's go back to the table, second graph. And now we can choose our values of x. So now what we're looking at is who is x sub 1, who is x sub 2, and so on. So I'll kind of refresh your memory really quick. Switch back for you. You kind of go back and you're saying, wait a second, who are our x values? Aha. So we should have x sub 1 equals 0. X sub 2 equals 5. X sub 3 equals 10. X sub 4 equals 15. There's a nice little step increment there. X sub 5 equals 20. So if you were really looking at this, although you don't really have to write it if you understand this, you still have this 0.2. But as far as function notation is concerned, what do we have? F of different numbers at any given time for those x values. All I'm doing is just kind of helping you out. Sometimes it's nice to have notation. So again, who's x sub 1? 0. X sub 2 is 5. X sub 3 is 10. X sub 4 is 15. And x sub 5 is 20. So if you understand this, all you have to do is figure out who are your values. And we can find that directly from the table. We'll switch back really quick. And I know you're like, oh, I already did it. Yeah, you did by hand. But I just want to demonstrate it that there are ways that we can make our life slightly easier. So again, we're plugging in what happens when we have 0. What happens when we have 5, x equals 5. What happens when we have x equals 10. What happens when we have x equals 20. Well, I'm going to go with 15 first. That's what we were looking for. And x sub 5 is 20. Then we have it. So those are the numbers that we were getting by hand with a little less complication. I mean, I know you're at a high level now. You can do all of this by hand. Yeah, I know, Leica, but I just want to give them a shortcut. That's true. I know. So all you have to do, for the most part, just kind of keep track of everything. There's a lot of bookkeeping. So again, we do have 0.2, and we do now have all these values. If you kind of compare this what you have in your calculator screen, we ended up having f of 0. What is that? So we have -3 plus 22 plus 97 plus 222 plus 397. And you're noticing, oh yeah, it is the same thing we were getting. 0.2 getting multiplied by the sum of that was 735. So in the end, we get 147. So sometimes I like to simplify the notation. I combination of using a TI with hand. But I really think the most important part of this problem is understanding this f of x of I notation. If you automatically understand that it's really just you expanding out functions with different values of x's, then it's a lot of plugging into formulas. So take some time to really practice on that. Again, we use this a lot in the next classes that you take. And the more you practice, the better you get at it. So I hope this helps. I will see you in the next section.